Halo, good afternoon, selamat sore. Assalamualaikum warahmatullahi wabarakatuh. Salam sejahtera bagi kita semua. Selamat datang di tayangan webinar series Connect 2.0 by Arkitekton Lima Tama. Terima kasih buat Arkitekton Lima yang sudah mengajak Anabata untuk berkolaborasi di dalam tayangan webinar ini. Hari ini topik kita adalah rethinking materiality from local resource to advanced technology and brought to you by Byo Living and Asahimas, dan juga terima kasih untuk media partner Arsify dan juga Arsitak. Saya Brian, mewakili dari Anabata. Saya tidak berlama-lama untuk opening pada sore hari ini. Silakan bisa menikmati dimanapun berada dengan popcorn, dengan kopi atau dengan apapun obrolan-obrolan di sore hari ini. Dan saya langsung saja undang perwakilan dari Arkitekton Mbak Novia untuk memandu jalannya acara. Please welcome Ibu Novia dari Arkitekton.
Thank you so much, Brian. Okay, good afternoon, everyone, and good evening. Thank you all for finding your time and visiting today's webinar. My name is Novia, and I will be the moderator for today. I work for Arkitekton Lima Tama. Arkitekton is an architectural firm founded in 1996, which since then has accomplished many projects in various cities in Indonesia, most of which consist of commercial, hospitality, and office buildings. So in the framework of its 25th year of work, with this webinar series, Arkitekton is trying to explore topics that promote sustainability and open discussions that are expected to contribute to the next step of its course, and by all means, the development of architecture in Indonesia. So, yeah, as mentioned before, our topic will be the rethinking materiality. So we will talk about the material usage in architecture. And I think this is a very interesting webinar because today we have three expert speakers from different backgrounds. So we have Ibu Veronica Soebarto from School of Architecture and Built Environment, University of Adelaide. And then we also have Handhyanto Hardian from Research and Development Department of Byo Living. And then we also have Popo Danes, the architect in practice, Indonesia, from Popo Danes Architects. So, yeah, before we start, maybe I would like to explain how you can talk to us during this webinar. So communication is available via the chat. So you can type your questions anytime as we go. Please go to the Q&A panel below. So we will answer the questions after the presentations. And then our first speaker will be Miss Ibu Veronica Soebarto from University of Adelaide. Veronica joined the University of Adelaide in 1996 after completing a postdoctorate research associate position at Texas A&M University in College Station, Texas, USA, and PhD and Master of Architecture degrees from the same university. She is the leader of the Sustainability Research Group at the School of Architecture and Built Environment and of the Sustainable Built Environment Research Team of the Faculty of Engineering, Computer and Mathematical Sciences at the University of Adelaide. Her research interests span from age-friendly built environment, environmental performance assessments of buildings, building performance simulation, building monitoring, human thermal comfort, to the social dimension of sustainable design. She is a fellow of the Architectural Science Association as well as of the International Building editor of Architectural Science Review Journal. And also editorial board member of Journal of Building Performance Simulation and of Energy and Buildings, Elsevier UK. Veronica is currently the guest editor of special issue in Advances in Research for Resilient Cities and Building Energy Using minimization for energy and buildings journal. So without further ado, I will pass the mic to Ibu Veronica. Please, Ibu Veronica, you may start your presentation.
Okay, cool. All right. Can you hear me? Okay.
Yeah, we can
Yes,
hear you.
we can hear you.
Good. And the slide is on the screen.
Yes.
Yes. Good. Okay. All right. Well, thinking about materiality, in addition to thinking about space, uh, visual impact, proportion, texture, um, shape, aesthetics, and so on, is one of the things, or not, if not the main thing that architects would think every day. Therefore, I feel really honored to be asked to talk about this very important part of architecture to the architecture community in Indonesia. And I particularly feel very honored to be asked by my senior, Mbak Cikita Pitono, who was several years above me when I was at UI, and also who is the friends of two other seniors of mine, Mas Hendra Jaya and Kak Toga Panjaitan. So I really feel honored to be asked to share our research in this area at the University of Adelaide, particularly to the community that is very close to my heart, which is the architecture community in Indonesia. So I was asked to talk about advanced building materials. What are advanced building materials? I use the definition by the European Commission that says advanced building materials basically are the new generation of construction materials that demonstrate exceptional properties. Well, what are those exceptional properties? I was asked to talk about this in the context of sustainable architecture. So in my view, in the context of sustainable architecture, one of those exceptional properties that advancing building materials should have is at least it should be materials that will minimize environmental impact. Now, because my talk will be mostly about building envelopes or materials that will be used for building envelope, particularly of building facades, walls, glass, windows, and so on, there's one particular environment performance that building materials has that we need to pay attention. And one of those is how could we use building materials that will minimize operational energy of buildings? Why? Because the building envelope is basically what connects the inside to the outside. At the same time, it is the part of the building that protect the people from extreme elements from the outside. In the context of hot climates like in Indonesia, that is about minimizing the heat coming from outside to the inside. Because if you design a building where you don't consider about these properties of the materials, because of the heat from outside that cuts through the building material or through a building envelope, your internal space can get quite warm. In a modern building, as a result of that, what do? We then turn on the air conditioning, and air conditioners obviously use a lot of energy, and it will use electricity. It would cost us to operate the building. So how could we have building materials that they can minimize operational energy? I think is one aspect that we need to think about. However, often we also forget that building materials also consume energy to make it, to construct the building, to maintain it, to refurbish, or to dispose it at the end of the lifetime of the building. So this is something that I think advancing building materials need to also consider. So minimizing the operational energy at the same time, minimizing the embodied energy in order to reduce the environmental impact. Now, the first part of my talk is going to be about advancing building materials for building facade, in particular on glass. Why glass or glazing? I think because I think glass buildings is like, or the glass itself, it's like the face of most modern buildings. We love to use glass. Why? Because on one hand, the glass can protect us from the elements, from heat, from rain, and so on, but also allow us in the building to still be able to enjoy the view outside. So these are the 3 buildings that I found that even the buildings are rated as a green in Indonesia, and it's full of glass. Now, what's the problem with having glass? I'm sure most of you know this, but sorry, I just have to kind of go back to the basic. First, glass has issues because it would receive solar radiation from the outside, and then some part of this solar radiation will be reflected. Some would be immediately transmitted. Some would be absorbed, which then will be either re-radiated to the inside or the outside. The part that is radiated inside becomes a long-wave radiation, which means it changes its property from short-wave radiation to long-wave radiation, and it gets trapped into the building. And so if you don't have opening or openable windows, what would happen? This heat is trapped in the building, and again, in modern building, the way we remove it, then we put in air conditioning to extract the heat out, and then we put cool air in. So we could reduce the amount of heat coming to the building, and the 2 properties that we need to look at, one is called U value, and sorry, this is a bit technical, but U value, or sometimes we call it conductance. So basically it is the rate of heat transferred through a material, in this case, the glass. So single pane glass, just clear glass, could have the U value about 4.8 watts per meter square degree Kelvin temperature difference between inside and outside. As you can see here, this when you put double glazing with argon filled gas or triple glazing and so on, the U value becomes less and less. The other property is what we call solar heat gain coefficient, which is basically the percentage of solar heat gain which is directly absorbed by or transmitted through a glass. Again, the higher solar heat gain coefficient, the more heat coming to the building, the less it is, the less heat coming to the building. Now, the difference between the 2 is that this is when you have direct solar radiation, whereas at nighttime, if the outside temperature is still higher than inside, the heat would still be conducted by the glass. So U value is conductance, solar heat gain coefficient is the heat transmitted. So what we want is minimizing the U value as much as possible, or as much as realistic, but also try to minimize solar heat gain coefficient. Now, minimizing solar heat gain coefficient can also be done by, just putting external shading. So whether it's, in a small house, we could have shading, we could have trees in front of the building. In a big house, in the big building, you could have external shading. And external shading, in a way, could also be sort of reflecting the architecture of the building. This particular one has this quite intricate external shading devices where it blocks the western sun, which is a bit warmer than the other side of the building, and the northern southern part of the building has some overhang and some fins like this. Well, what's wrong with putting this onto the building? There's nothing wrong, except that in a bigger building, as you can imagine, it could be quite difficult to maintain it or to keep it clean. You can imagine if birds fly into it and put droppings, or we call it poo, and you can imagine that these just get dirty very easily, and therefore somebody has to clean it, and you can imagine how difficult it is to clean it. Another strategy is using what we call reflective glazing, and it can be quite efficient or effective to minimize the heat gain to the glass because it can reflect up to 90% of solar radiation. And I remember back in the early 80s, one of the first buildings in Jakarta that had reflective glazing, I think it was the Lipo building in Kuningan. And I remember when I went to that building, I used to stand in front of it and I thought, wow, that's a mirror. So I can use it to, kind of brush my hair before I have a meeting inside the building. Anyway, the problem with reflective glazing, however, is while it reduces the heat gain, it also reduces the solar radiation in terms of the light, the visible transmission. So as a result, the building can get darker inside the building and you have to turn on your electric lighting. So whilst you reduce the energy for cooling, now you use a lot of energy for electric lighting. So I don't think reflective glazing is quite smart. In the past, I suppose in the last, the end bit of the 20th century, there has been some new development, which is something called smart glazing. Sometimes it's also called chromogenic glass. So what is it? This type of glass basically can switch the thermal and optical properties of the glass depending on the outside condition. So some glass which are a glass that can switch its property using some sort of artificial devices. It could be some sort of gas that is put between the pane or the two panes of glass, or you could also induce it with electricity using what we call electrochromic technique. Basically, it then switch the thermal property of the glass, so it becomes darker when the sun hits it, and then it would start to almost like behave like reflective glazing. So it reflects the heat to the outside. And then when there's less heat from the outside, it starts to clear up again, and then it allows the sun to come into the building. The other one is the natural device. So the kind of glazing that does something like that, but without these external devices. So one is called photochromic coating. So basically it reacts based on the amount of light that goes to that the glass. And the second one is called thermochromic coatings, which is what I'm going to talk about here. Basically, if there is a higher temperature on the outside, the glass becomes darker again, and then it reduces the amount of heat that goes into the building. And then when it becomes cooler, it becomes bright, or it becomes lighter again. It clears up this coating, the color, and then it allows the sun to come into the building. So in a nutshell, the way it works is something like this. Oh, sorry, there's something missing. Okay, they're here. So the sun would hit it, hit this glass, and then with this PVB or polyvinyl butyral coating, it would reduce the amount of heat coming into the building, and it would still allow some light coming to the building, while only a little part of that would be reflected out. And this is how it looks in kind of the most conventional thermochromic coating at the what we call the on stage, which is when it changes its property to become darker and reflects the radiation outward. However, at the on stage, the problem with the conventional thermochromic glazing is that it still reflects too much solar radiation, which also means it doesn't allow this visible solar radiation coming through the glass, and therefore the inside might still be darker. So thermochromic glazing now is the new reflective glass, although it doesn't happen all the time, but it seems to be that that's the case. So I'm going to, So before I go to the actual work, and I apologize that this probably seemed to be too technical for many architects, but it's very important concept. So basically, when the sun doesn't hit the glass, or when the outside is cooler than the inside, the glass is in the what we call the off stage, or the cold stage, and it's in the semiconducting mode. And then when the sun hit it and it starts to switch the property, it becomes metallic, and that's where it reduces the sun to come into the building. The change of this temperature often in the conventional one happen at the quite high temperature. Actually, the transition temperature is about 65 degrees Celsius. So if you can imagine, I think you probably can relate to this with, I'm sure some of you are wearing sunglasses or glasses that when you are outside, the glass becomes darker, and then when you go inside the room, it clears up this darkness. It's similar concept, although that is more, or that's what we call the photochromic glass, whereas this is the thermochromic glass. So it's not based on light, it's based on the heat that is received on the surface. So this is actually, I'm presenting the work by one of our new PhD graduates. She's now a doctorate, Marina Aburas. She did our PhD with us, also in conjunction with Department of Architecture at University of Nottingham in the UK. So she received 2 degrees in this. So what she developed basically is advancing this thermochromic glazing using vanadium dioxide nanoparticles. So you probably heard nanoparticles. It's a very minute, very small, 1 to the billionth of meter. So it's very minute particle that she applied on the coating, for the coating, to make this thermochromic glazing, with the idea to increase the visible transmission of the solar radiation while still minimizing the heat transmission. And also what she tried to do is reducing that temperature from high 68 degrees to 36 to 40 degrees. What it means is that the glass doesn't have to be so hot that it would change the property. It can change at 40 degrees, which means then the glass doesn't get too hot. That means there's less heat being generated or transmitted to the inside. So it tried to cool the building much quicker than the conventional thermochromic glazing. Now, this is a work of many, many years, or 2-3 years, 2.5 years. So I'm not going to show you in detail, but basically she applied, or she developed these vanadium dioxide nanoparticles using ultrasonication stirring, and then spin coated, and then applying thin film microscopy, and it's become a thin film on it, and then becomes the final product. And the final product, she also applied several layers, so from 80 nanometers to 800 nanometers. So the more layers, of course, is darker, the less layer is less. Now, this is the exciting thing. So if you remember the graph that I showed you before, the conventional the conventional thermochromic glazing tend to, when it's at the on stage, have a look at this, the percentage of solar radiation that comes to the building is only about, about 17% at the on stage, which means you reduce so much light into the building. And this is what she was able to develop. With an 80 nanometer glass at the off stage, let's say you got about 80% solar transmission. When it's at the on stage, it is reduced it by 10%. When it's, let me jump to the 500 nanometer, it reduces to 60% transmission, which is you still have a lot of light. And even the thickest one, she could only reduce the solar radiation to 30%. So you still get light coming to the building. So what she then did is apply this glazing to a hypothetical building, so an office building, kind of typical office building, and use building performance simulation to see the impact of this glazing. So I'm just going to ask you to look at the focus on the hot climate, which is the building in Cairo, hypothetically in Cairo. And of course, Cairo is not exactly the same as Jakarta, but it is hot. But of course, it's hot and dry, not hot and humid. But have a look at the impact of applying that coating. So if I just jump again to the 500 nanometer, basically you could reduce the energy by 25%. And if you use the thickest one, you could reduce by 40%. So nearly half of the energy used for cooling can be minimized. And the increase in the lighting energy, because it does, true, that the building gets slightly darker than before, but the increase in the lighting energy is almost negligible. So it's very small amount of increase in lighting energy, but it has significant decrease in cooling energy. So it is possible to do that using this new technology using nanoparticle thermochromic. In addition, she also look at how useful the daylight that gets into the building. So the target is, if possible, to achieve between 500 lux to 2000 lux of what we call useful daylight illuminance. Although 500 lux itself is still quite high. So in most green buildings now, 300 lux is considered sufficient. And this is what she found. So if you just look at double glazed windows, you got a lot of daylight, obviously, but at the same time, you got excessive amount of daylight, even up to 5 meters from the window. So this is the distance from the window. With the thermochromic glazing, even with the thickest one, you still have quite a lot of daylight, useful daylight coming to the building. Yes, there's a lot more that is less than 500 lux, but as I mentioned, in new green buildings, we don't need to have this 500 lux. 300 lux is already sufficient. And with it, it also reduces the possibility of people experiencing glare because you don't have excessive amount of light. So the daylight is a bit more evenly distributed when you use the thermogenic glazing compared to single glazing, when you got really bright area in the front and then quite dark at the back. So where's it going to be in terms of this invention? Of course, she only just finished the PhD, so hopefully manufacturer might pick up on this idea and could start manufacturing in the larger scale. So that's the first part. And how do I go with time? Am I still okay? Okay. So the second part is quite the opposite. So whilst the first one is looking at the glazing, the second part of the presentation is looking at the wall itself. And also it's quite the opposite in terms of the materials. This one is looking at quite low cost, well, I shouldn't say low cost, but it's basically using vernacular material, however, with high-tech way of constructing it. So it is about development of earth-based construction using 3D printing technology. Now, I'm sure many of you, if not most of you, are quite familiar with what we call digital fabrication. So digital fabrication basically could be a 2D fabrication, just using laser cut. And I'm sure many of you build physical model now using laser cutters. Or you could use 3D fabrication. And with 3D fabrication, you either use it as a subtractive or removal method. So let's say you got a block of material and then you start cutting it and you make the model. Or you could have the additive method. You add the layer by layer of materials, again, make a model. Or with the formative method, so you form any kind of shape you want. Whereas on top of this is the 2D laser cutting. Also, a lot of 3D printer or the conventional one has 2 axes, so X and Y, so you only print at the 2XY direction, whereas robotic printer, you can print it with the 3-dimension or 3-axial direction, so X, Y, and Z, basically. What my PhD candidate has been doing is basically using this robotic arm printing, but not just to build a model, but it's to build the actual building using this digital fabrication technology. So it's basically building a wall using a real wall using a 3D printer. So this is what I'm going to talk about. And why do we use 3D printing? So when he actually brought this idea to me, I was quite skeptical. And I said, what's wrong with building with people? And why can't we just build with crane or with normal construction technique? Well, and he's able to convince me, basically, when you use 3D printing or 3D printer to build a building, you potentially reduce the construction waste. Because as you know, those of you who do 3D model using printer, you have to program the printer, which means you can program it so it will only use material as you need. There's not going to be much waste. Whereas if you build with conventional way, let's just say, because building material comes at certain size. Let's say a timber beam is 4 meters long, and we want to build something which is 3.5 meters long. What do? We have to cut it, right? Now, what happened with the 0.5 meter? Hopefully you can recycle it or use it for something else. But my experience is a lot of construction site, you got these leftover materials. Why? Because either the material is longer than what we want, or we don't design and build based on the available size of material. So we change the size because we think, oh, well, we can cut it anyway. But what happened now, we start having a lot of construction waste. Also with digital printer, basically the idea is you could build in remote sites. So say you got disaster area and it's hard to access it by big trucks and it's hard to have a lot of workers working in there. With 3D printing, theoretically, what you can bring is bringing it with a smaller truck. You put the robotic arm on the small truck and you can build it using the local material rather than bringing in big trucks. So it potentially would reduce construction time. But then you said, what's so special about 3D printing? Like countries like China has done 3D printing for so many years now. This is on the top right side is 3D printing or 3D printed building in Italy and even countries like Morocco. The lower right-hand side here, that was a building that I saw in Morocco at the University of Muhammad VI site. They actually experimenting with 3D printed building. The issue is, or the argument here is, most, if not all, large-scale 3D printed buildings at the moment use concrete. Concrete as a material has high embodied energy. So if you look at this chart here, basically concrete, particularly aerated concrete, it got quite high embodied energy compared to even concrete blocks. But if you use earth materials, you immediately reduce the embodied energy quite significantly. So what he tried to argue is we can use this advanced manufacturing technology, but let's adopt vernacular materials that has low embodied energy, and that material is things that we see every day, just local soil. So this material, some of you must have known this, it's called cob. It's not corn on the cob, so it's not corn, but it's actually just the name is cob. It's basically made of earth or subsoil mixed with water and with fiber to bind it. And it usually is straw. I think, okay, we call it jerami in Indonesia. So that's very traditional material. And sometimes you can add sand or clay. It's optional. Now you might say, that's a bit kampungan, isn't it? Why do you build materials using this dirt? Yeah, it doesn't look nice. Well, you might be surprised that earth building can look really beautiful. And on the right-hand side, this is not cob. This is something called ram earth. Basically, it's a mix of sand, clay, usually gravels, not straw, and water, and you ram it. And it just creates this, to me, it creates this beautiful texture because it depends on what type of soil you use, and you got this natural look of different layers of the earth materials. On the lower left-hand side here, that is another, it's actually a large building using cob as material. So you could use cob for a modern building. So it doesn't have to be a building that you expose this natural material that you probably think, oh, that looks, pretty ordinary. You could even plaster it, hopefully with the low embodied material plaster, like lime-based plaster, and you can make it looking quite smooth and clean. All right, so what did he do? Now, because if you use concrete is a bit more liquidy, so it can print very quickly or easily, whereas with cob, as you can see, when you build it cob by hand, it's easy to mold. But when you put it in the nozzle of the printer, it's harder. So the first thing he did was trying to find the most suitable mix for the printing, for the printer. And then he also looked at different type of pattern for the wall materials, and this is him in action. So again, several pattern of the 3D printed cob. And interestingly also that this technique can also be used to print a wall that is not just vertical, even on a curve, on a tilting angle, and so on, it could also work. His idea also, in the nutshell, is that we could also deploy this technique for, say, building in a space. So let's say we want to build a shelter, I don't know, in the moon one day, or in Mars. All you need to bring is just the robotic arms and another robot that would move this robotic arm and use the local materials to build the structure. Of course, the question is, where's the water coming from? Because say in the moon, you don't have much water, but there's some part of the moon that might be ice, and the ice can be melted with solar panels, and then you can use the ice, the water, the melted water to create the mix. We haven't experimented with this, obviously, but the idea is there. So what he did was not just experiment with the shape, but also with structures, and to look at the structural capability of this, and found that 3D cob walls can sustain structural adequacy for less material because you don't need to print as solid material. You actually reduce the amount of materials, and this pattern actually becomes kind of provide the structural strength of the wall, and it can actually be used for even two-story buildings. He also looked at the thermal conductivity because we also want to see how it is performing in terms of trying to minimize, again, cooling energy into the building, and found that the 3D printed cob, because of the gap, because of this air gap, it actually reduces the conductance. So it reduces the conductivity compared to the solid wall. So it is a promising way of a promising material that can be used for building walls. He also looked at what we call life cycle impact assessment. So not just energy, not just the structures, but also the overall life impact assessment. And very quickly, and he compared that with conventional COP, so COP that you did by hand, with 3D printed concrete, and as well as with conventional concrete. And what he found is that, I didn't mention the name of the student, apologize. His name is Muhammad Goma, he's Egyptian. And he found that with 3D printed COP, overall, it has the lowest environmental impact out of the other three. It is true in terms of the mineral resource scarcity and land use. It would use more than concrete because you use the soil. There's minerals inside the soil, but it uses much less water. It would potentially reduce the ozone depletion, significantly reduce the global warming potential. So, in summary, I guess the message that I like to share here is that as architects, let's try to explore new materials, not just based on aesthetics, but also based on their impacts, whether it's on comfort, cooling, or lighting. And as much as possible, try to minimize the embodied energy of the material. Also, if possible, implement efficient construction techniques so that we will minimize the construction waste. And by doing so, hopefully we can help try to minimize environmental impacts from building materials or from the construction techniques. Now, what of course I didn't address here is are the other impacts, such as impact on indoor air quality or acoustic quality or cost, which I think that's still a lot of things that we need to look at. But I guess hopefully this gives you some ideas of things that you could do or we could explore. And also we can develop further. If you want to know more details about the work, I will share this PowerPoint to the organizer. So those are two papers that the first student, Marina Aburas, did that talk about the thermochromic glazing, and then the last 5 papers, the one for the 3D printed COP that Mohammed did. With that, thank you so much for your attention. Sorry if I talked so fast. I just want to make sure that we get enough time for the other speakers. And I would like to thank you for hopefully not boring you too much. And it's good talking to you. And thank you. Assalamualaikum warahmatullahi wabarakatuh. Thanks, everyone. I will stop sharing. Okay.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you so much, Ibu Veronica, for your very interesting presentation. And it is very insightful, especially for us who work in the construction industry. And then you give us many insights to the new technology that could be implemented for the architectural development in different areas. The one for the housing and more small architecture, and one for the more high-rise buildings, like using more high technology. So thank you so much for your time. And then I will move to our second speaker. So our first speaker is from academic institution, and then our second speaker we have Pak Handhyanto Hardian from the material manufacturer. So he's a research and development from Research and Development Department of Byo Living, and he graduated from Institut Teknologi Bandung in 2011, and here's some of his professional works. He's the principal designer at Studio Hand from 2017 to present, and the chief of product design development at FASA in 2016. He was also a freelancer interior designer from 2013 to 2016. and he was an interior designer at HP Architect, Bali in 2013. Also, he was a furniture designer at Zep Design in Bali, also 2012, and he was in AXA Living Furniture for internship in 2009. So he achieved many awards. Here we can see that he was a finalist of Rosanna Orlandi Guiltless Plastic Prize 2019, and then American Standard Design Competition first winner in 2018, and Vivere LKS Chair Competition Gold Prize in 2016. Also Indonesia Furniture Design Awards Silver Prize in 2014 and Platinum Prize in 2013. He was also contributed in several exhibitions, including Indonesia Furniture Expo in 2014 to 2017, and he contributed International Furniture Fair Singapore in 2016, Indonesia Bamboo Biennale in Surakarta 2016, Chiang Mai Design Week Thailand 2017, Seminyak Design Week 2018 and 2019. Also, he contributed in Bintaro Design District in 2018, Maison Object, Paris in 2018, also Rosanna Orlandi Gallery, Milano in 2019. So without further ado, let us just listen to your presentation. The floor is yours. Pak Handi, silakan.
Hello everyone. Is it clear? Can you hear me?
Yeah, we can hear you.
Yeah, okay, so I'm gonna start my screen. Okay. Hello everyone. Good afternoon. Today I would like to share some of what we have done in Byo Living. Me as a research and development, product development in Byo Living. So this afternoon I would share about envisioning weaving for social and environmental impact. So let's start from now. Yeah, it started with the question that always appears in the realm of craftsmanship, especially in weaving craftsmanship. What kind of challenge are we facing now? There's a lot of challenge in craftsmanship. And the second question is, how does our weaving approach solve these challenges? So we have developed solutions for architectural need, and it is based on weaving and craftsmanship. So the first issue is to solve time and budget. So we create weaving technique which is very fast to make and also lightweight to apply, while creating one-of-a-kind aesthetic. This is one of the example of the project that we have done. In this project, we develop a very simple pattern, so we can achieve like a very fast production and low cost in production as well. The next solution is to solve the solar radiation problem. So, like explained before, that solar radiation is also important to for the interior of the building and also the exterior. So we create a lightweight second skin solution which can block as much radiation as possible and allows as much natural light as possible, and also allows air circulation as much as possible as well for the interior. So this is one of the example of the project that done by Atelier Riri. So as you can see that the facade building is made from the Byo Living woven. So So it still can block the sun ray from the different angle. Uh, it's obviously from the design. It has like a 3D structural of the facade, so it can block the sun rays from different angle, from top and then from left side or from right side. But it's still maintaining the good air circulation inside the building. So this is one of our example of the project. And the another solution is to solve the scalability problems in craftsmanship, especially because craftsmanship is all about handmade and it takes like a longer time rather than industrial product. So we're trying to solve the scalability issues with the example like this. This is one of our project in Tubaba. Tubaba is one of the youngest province in Sumatra, and we solve the scalability problem by engaging the local people to get involved in the project. So we empower them to create something they can proud of when when their work is displayed as a landmark of their town. So we with our technique we can transfer our knowledge to the local people to create a much bigger scale to apply it at the building or architecture. And this is from another side. So as you can see that it has a large like a hanging screen. So the scale it's very large and it can empower many local people to work on it. And we also develop interior system solution in here. For example, this is a 7,000 meter square eco ventilation that we have built for Toyota headquarters. We work together with Arab and Manhart for indoor airflow distribution while decoding Indonesia's 16,000 islands weaving technique in 2 years' time. So we've done a lot of research for the pattern that we're gonna use for this project, and it took like 2 years' time to get to decode the patterns and to apply it for this project. So this is the example. So we create a system to replace the conventional air conducting. So as you can see, there's no ducting installation in the ceiling. So the design actually allowed the air to streaming to all over the space equally. So it doesn't so it doesn't have like a conventional ducting to flow the cool air equally to all over the space. And this is the result of the pattern that we select from the 16,000 pattern, Indonesian pattern from 16,000 islands. So this is one of the example of the pattern that applied in the ceiling and for screens and for wall decoration. We also trying to solve the problem in the mid-rise building. So actually, we also developed a lightweight facade. This is the example of our client. They requested a special customization facade design to be attractive from far away, yet beautiful from the interior point of view. So it has two faces that faces outside, and also its faces inside from the interior. So we propose a rustic metal color, just like a hand woven with somewhat randomized the pattern. So this is the result. As you can see, this is just we are mimicking like a carton steel. So it's very catchy from the outside. And the next is, yeah, this is our spatialization. So we use graphical computerization to decode the like a complicated graphic. This is one of the example from our project in Okinawa Hotel. Here we go. So we are using the latest technology to decode the image into weaving pattern like this. With the pixelation method, we can translate the complicated graphic or pattern to the master weaver. So the master weaver will be easy to read or to communicate from the design to apply to the weaving like this. This is also the result. It has the same material, but we play in the texture of the image. So it's actually has a graphic, but it depends on how you look from the angle that you look. And we also develop a new design language for Japan architecture firm. This is one of the challenging projects that we have done so far. So this is the building that using a screen or a woven screen to be a wall. So we develop it in almost like 3 years, I think. So this is from the interior views. It has so many screens that can be a wall. Yeah, this is what we have done with the. This is our R&D process with the screen. So it has like a special joint, and we also make a special like a railing system to make it moving. And we also test the weaving. We combine the natural rattan material and metal plate to get the structural feel to make the screen robust but also aesthetic from the design. Yeah, and this is the first mock-up. Yeah, and it's still on progress, so I can share the final or the completed project. Okay, going to the next slide is from there we also develop a new rigid weaving that combined with the metal weaving. Here is one of the example. We did it for pre-hal exhibition of Andrea Martin last year. We developed a screen made of woven metal combined with a natural rattan to create a light structure but also robust structure. This is the details that we've done. We combine the metal weaving with the natural rattan weaving. And here is the result. And we also doing some artwork project like this. This is our project for Heme. We commissioned to create a retail space weaving installation inspired from dreams. So we create an optical illusion effect with the natural rattan material. We use approach of creating mesh thousand lines to visualize it between illusion and reality. Through our artisan spirit, we want to capture the essence of timeless luxury by creating different perfect weaving lines through careful selection, high rattan material, new knotting craftsmanship, rigid poles with careful linear rattan arrangement. So this is what I'm talking about, the optical illusion of the rattan material. And this is the pop-up store. It's when you go through inside the stores, you will have like a optical illusion effect. It depends on how you stand or how you see the linear rattan material. And here also one of the effect that it can make the linear rattan glows inside the store. So yeah, and this is also the result of the computerized graphic pattern from our team. This is the details. And this is how the master weaver do the weaving. And now we are developing material from waste as well. Since 2 years ago, we have been developing weaving materials from plastic bottle waste, working together with Remco Haas, the OMA team. We create one-of-a-kind translucent weaving sealing system, which also work as architectural writing solution arranged by Takeo Sugamata. This is the process. We have recycled around 6 tons of plastic bottle. We use the green plastic bottle to make straps, and then we weave it to apply it at the ceiling of the new Potato Head Hotel. And here is another application from the recycling material. We use it for the furniture as well. And we also use the recycling material for screen at the restaurant. Yeah. From there, now we are expanding our development to find more material which is based on waste material. So yeah, looking at so much plastic waste problem, we create our own in-house initiative to develop new buildings material, which is elegant, durable, extraordinary, different sort of plastic waste. And this is one of the process, the example, and we create like hotel signage. This is also from Potato Head project. Tanaman. And this is our latest development. The plastic waste can be also applied in furnitures and also panel. The right hand side is a waste from it's a industrial waste from a packaging factory. It's a polypropylene and high impact polypropylene plastic. So it is translucent, sort of like a acrylic material. So we try to recycling it and apply it to be like panels for glass or for partition. This is the another development that we did. We also used the material, the high impact polystyrene material to make a sort of tiles and walls from it. The right hand side is actually charcoal. It is a waste from the wood industry or furniture industry. It actually it's the wood is sometimes it end up in like a in a trash and they will burn it. So we try to explore the material to become something that is aesthetic but also have like a function like uh, air filter or something from charcoal. This is the another exploration that we did, and I think that's all that I can share to you guys. Thank you for your attention, and if you have any question and wants to know further, you can chat or ask after this session. Thank you very much.
Okay, thank you very much, Hani, for your presentation. That was a very nice presentation.
Yeah,
Yeah, yeah.
quick.
Yeah, I think actually I really like the idea that Byo Living use that weaving techniques because it is lightweight and also Byo Living transferring knowledge to local peoples and um, uh, make the local workforce have that creative way to um, contribute to the construction in architecture or architecture. Also, the idea that Byo Living using plastic waste and other waste in the materials for your production, I think it's very good. And thank you very much for the presentation.
Thank you.
Okay, and before we head to the last speaker, we will have a very short break. So please don't go anywhere, stay with us, and we will come back to you shortly. Thank you.
arsitek sangat memperhatikan masalah sustainability dan peningkatan kualitas hidup. Pada acara ini, kami dari Wonders of Weaving ingin mengusung tema well-being. Kumpulan instalasi well-being di ArkID diwakilkan dengan 3 tema, Serenity, Relation, dan Reliving Gedek. Wonders of Weaving adalah satu collaboration platform yang mengembangkan kerajinan tangan yang bisa memberikan solusi terhadap sustainability. Pertama kali kami diundang oleh Maison Objet Paris pada tahun 2016 untuk melakukan satu pameran yang mana pada pertama kalinya kami mengangkat tema Wonders of Weaving untuk mengembangkan kerajinan tangan berpusat terhadap solusi ramah lingkungan bagi arsitektur.
Hello. So we are back and we still have our last speaker here, Popo Danes from Popo Danes Architects. So, hello Popo, are you ready? Yeah, okay. Maybe I would like to read the biography first.
Hello, everybody. Yes.
Okay.
Can I start? Yeah. Okay.
So I would like to introduce you first.
Okay.
Okay. So Popo Danes is a native Balinese who grew up along with the unique culture of Bali. He comes from a family with an agricultural background from the northern hill of Bali. Just like any other Balinese families, his family also involves in the local culture as part of their daily routines. Popo developed his interests in architecture since his childhood times. It brought him to study architecture at Udayana University in Bali and graduated in 1991. He started to work as a freelancer and finally established the company Popo Danes Architects in 1993. In the same year, he also got his first international project to design one five-star restaurant in Dubai. As a Bali-based architect, he can't get away from the tourism industry as it is the vital economic engine in Bali. He specializes himself in designing tropical resorts with cultural influences in it. As he was also very active in environmental movements in Bali, he tends to put attention to ecological issues in all of his design processes. He strictly refuses to design on the building site, which also works as a wet farmland, and therefore most of his project sites are on unfavorable locations with irregular shapes and slopes in the countryside, which now become his specialty as well. His experiences in art and cultural activities in Bali also led him to harmonize them in every design projects. Popo Danes then achieved some significant architecture awards nationally and internationally. Besides his practice, Popo Danes acts as a speaker in conferences, book publications, and architectural exhibitions. He's also an active ASEAN architect since February 2017. Okay, so maybe you can start the presentation now, Pak Popo, please.
Yes.
Yours. Okay.
Good afternoon, Novia, and good afternoon, everybody. Thank you for the introduction. And yeah, I would like to start this session with some the way I can put myself, my positioning in relation with the topic of the webinar this afternoon. So we are based in Indonesia, a very rich country for natural resources. And as an architect, we always try to connect ourselves to the very main source of all of those materials. Especially as we live in Bali, we are dealing also with the daily creativity of the people, and we always understand of how we can develop those natural material like what Byo Living does in their business, which is I admire a lot. And in that way, we always understand like where is something coming from to contribute our architecture, which is also develop another level of sensitivity in using this material. For instance, if I have a bigger size of project, I always feel disturbed as well. And like if I put this volume of concrete, there must be damage happen somewhere else because we are taking materials from quarry and we are using some wood from the forest and everything. In contrary, I do have a lot of collaboration with an architect in some other countries through our overseas projects, and I found the mindset could be very much different because like for some other countries, let's say I can mention the name of the country like Singapore or Dubai, for instance, their main resources is capital. Money can buy anything they need. Yeah, the best thing they need, they can collect. And like in one TV program, I was following one session with one world famous architect, and he was talking about, yeah, we were transporting some 1,000 tons of steel to put together for this project, and why this guy got no guilty feeling? Probably because he have no idea about what happened in the quarry where they collect the raw materials of the steel, probably. And this kind of thing keep becoming a concern for us, and I'm taking it in a very positive way, and we think this is another opportunity for us to create another level of thinking, yeah, because we are glad we are close to all of those production and supply line, and we understand all of the impact directly. And I think I will later on explain through some example what how we handle the situation in every project. Now I will start to share some slides about our project, and I think in that way I can do a better storytelling of this session. So this is about the materiality, and yeah, first of all, not only the material, but we also try to control the mindset of the project. Yeah, like yeah, maybe some of you understand we are more specializing in the rural kind of project. We are doing a lot of resorts, especially in the sensitive side, and we do design work with some guilty feeling because we we will start to damage one location and put some size of architecture on it. So this is one of our first resort project we did in Ubud in the mid-90s. And as you can see in the slides, we use a lot of wood material for the structure and the interior of the resort. At that time, the price of wood was still very cheap in Indonesia. Like during this time, if I put it in US dollars, the price of the Merbau wood was about only $60 today, which is very much affordable. Then I can use and play with wood so much. And as a comparison, the price of Merbau wood today is about $1,500 per cubic meter. Because of this project, I got one opportunity to work on another wooden architecture project, and apparently my client was the owner of one forest, wood collection in the forest in Borneo, and I was witness myself how they chop our forest and destroy all of the nature in it. Yeah, so since that time I always becoming very sensitive with using wood and very careful only using wood at the most essential part and must put the right value for the material. Yeah, and also we are always trying to bring the original image or original idea of the architecture, the traditional idea, to transform to become a new modern facilities. As like for this structure, we transform the traditional granary to become a daybed in one resort. So like this project, I was really scared when we did this one, because we transformed one very steep hilly site to become a resort. And we also put some hard materials, concrete on it, but luckily we managed it well, and we can see the result. The condition of the site is much better after we have the resort actually compared to before, with some additional economic value in it. So we can also transform the original idea of Balinese natural landscape to become a resort setting. So even like for this one, we can use this. This is a modern outdoor inclinator, but we can clad them with the bamboos and make them look more organic and more suitable to the setting of the site. And same like this resort, because the site is very steep, we are trying to make the building as light as possible. And we found this inspiration from the traditional architecture in one remote village, and we wave the bamboo and we transform them to become a thin clad bamboo as a wooden as a wall panel of this villas. And we implement this in the 25 villa we put this resort. And like this is our design studio. I'm currently sitting in this room, and in this building we put mostly recycled materials. All of the wood here are recycled, and I'm happy to know where is this coming from, what it was before. So somehow it's also create a more storytelling about design elements in our project. The meeting room, this post was the footing of the jetty in one harbor in East Kalimantan, and we use a lot of recycled wood from the boat. And yeah, and this is becoming like the materials we are dealing with from time to time, also bamboo. Yeah, and the craft can help. How can we beautify those simple material? we use the stone for the cladding, for instance. Yeah, and the other case, we were transforming the old set joglo in the poor villages to become a new, fresh structure in the glamorous setting, I could say, like the joglo structure in Java, mostly located in the village. But I appreciate the material. The joglo in Java is always come out from a very beautiful and precious kind of thick wood. And we can do a new setting and a new energy, and it's become a new fresh building, and even could become a luxury resort, as what we did here in the southern part of Ubud. This was an old granary. We transformed it to become a guest bungalows, yeah. And every materials are recycled from the old materials, and here we are using also the bamboo shingle, which is very sustainable as a renewable material. Yeah, and this is becoming one of the essential element of our pride working as an architect. And once we are talking about the sustainability, then we also can move to all of the other aspect of sustainability, like this project is talking about energy. And I could consider this project as the first project in the off-grid base. Yeah, we are using solar system, and this was actually done like 6 years ago, and honestly today looks like a kind of old-fashioned, because the solar energy system today is already much more advanced, and we can use some good materials and much better looking panels and also energy storage for the project. But in the other side, to complement this project, we also did a lot of special touch, like some of the interior part, like this, all of this paneling. We use bamboo. We were collaborating with one company, Indo Bamboo, who has the processing system of creating engineered bamboo to make them equal the strength to the ulin, the ironwood in Indonesia. So then the good thing, the good idea for sustainability and also the sensitivity to the environment is always can collaborate together through every design. And in this project, we handle the material issue differently, because this was an old project from the early 20s in Lombok, where actually at the beginning was a completely damaged structure, but we found a lot of beautiful elements that we can maintain, and we can of the architecture, and we redeveloped this old structure to become a newly built fresh restaurant, but keep using all of those old elements. And luckily we found all of the source to find the old material, like the stained glass we can copy. We found some of the leftover stained glass, and we copied them in Surabaya, and we them back as the facade of the restaurant in the front doors. And we also found the same kind of roof tile, the clay tiles in Bandung, as well as somebody who terrazzo floor tile from Pasuruan. And it's becoming a new residential project in Sanur. Then we also even do a copy of an ancient material or technology, but also in terms of style, we were copying the old style of the temple. This is the very rare style of in North Bali, as well as some implementation of other material usage, like for instance the bamboo woven the bedek we use for a door panel, but we use another material to make it more durable, and we put some aluminum sheet to become the material of the bedek of the bamboo. It's also set well together with the recycled wood frame, and we put bamboo as well, another recycled floor, recycled wood for the flooring, and like everywhere else in every elements we are also using the same kind of technique, and like how can we combine the opening with the technology. Yeah, and I mean when we put them together, it's becoming something like this wooden door we can put in the quite a big span, good material for the framing, and also the good cosmic and the modern, the tradition and the technology, and creating something at the new platform. With this, and we can get a lot of support, like also this ceiling material, we are using a recycled aluminum, and how can we put them together as an installation art, and looking good and looking special, and very much complement the entire architecture and setting. For this project, because actually the biggest asset of this project is the vista, the marvelous view. So then we are trying to reduce the use of materials in a very minimalistic way. We put mostly only a very simple concrete, polished concrete, and the architecture, we only implement the most basic element of tropical architecture, which is only post and roof. So the rest, we keep them open, and the building is so transparent, and we are also not blocking the view for other people in the surrounding. But we also never forget to include some touch of local culture as the identity, as a standalone statement. In this case, we use the old ancient gate of North Bali as an accent of it. So this is one of our we found like we the nature and the new function, and also the local materials and the local craftsmanship, and to become a luxury resort. And we adopt as much as we can the local architectural elements, and this project very much trying to follow the rule, still using all of the very basic local materials, which was done by the local craft people. And I was very much amazed on the spot without any pencil pattern or whatever, and everything just flow like that, and we can transform the traditional function to become a modern function. And this resort just got one special appreciation from UNESCO through the Prix Versailles last month as the best hotel in Southern Asia. I believe they were considering the implementation of culture and local building elements in it. So we also use even the soft craft like the textile to become the screening and also creating the shadow. And yeah, we do it in the several different level, and where we can do it in the raw shape, and also some of them in the fine finished product we use. And I think this is some of the example of the way we are playing with this material, and also how can we introduce the richness of our art and culture to the audience. And we are glad because this is, for instance, the material of this presentation are most of the work which was done locally, either in Bali and some other island in Indonesia. But through the formula we were created in Bali, the way we can collaborate all of this component, we are now also got a lot of opportunity to implement the same kind of formula in the other country where we have also a similar kind of ingredients, components of material and craft, such as in India, and also currently we are quite busy in the Philippines. So I think that is the material I can share. So I hope we can be more active later on for the question and answer. And I really hope personally that this kind of system also can be applied in some other part of Indonesia. And I'm looking forward for some other opportunity in the near future to share some more projects. So I think I'm already using most of my time, and thank you very much for the attention.
Thank you very much, Pak Popo, for your presentation. I was mesmerized looking at your slides. It makes me want to travel to Bali. Okay, so it was a very good presentation from Pak Popo Danes, and I think this type of architecture always has its own charm, you know, because the way it's done, like it tries to invite people, and then it tries also to preserve the natural environment. And I think it is a very good thing to do for an architect, and I think you did very good, because obviously you make me and maybe everyone here wants to travel as soon as possible after this pandemic. Okay, so you already have some questions in. Maybe I will read one by one. Yeah, actually we have first questions here from anonymous attendee to Ibu Veronica. Maybe I will read it to you all. Actually, it has been answered, but maybe Bu Ira wants to answer live so that everyone can hear and give their opinions too. So thank you, anonymous attendee. They have two questions. Thank you for your amazing presentation. The first question is, using soil as a building material is really a good idea, but have you considered the possibility of overexploitation of soil, as happened in Vietnam, as a small island disappeared due to the excessive sand dredging for export abroad? And then the second question is, how can 3D printing impact positively the local workforce, especially in developing countries? So maybe Bu Ira.
So yeah, I tried to answer that already. So I guess, look, obviously we should not exploit anything as much as possible. I think Popo just said, you know, even if you use, we often never question if you use concrete, you just use it. But somewhere in the world, also in Indonesia itself, there's some part of the natural resources that got exploited. You use timber, or we cut timber in Kalimantan, you know, we overexploit that. So of course we should avoid any overexploitation. So if that would ever happen, well, we have to stop it. The issue, however, I mean, with earth construction, the initial idea, or the original idea, and I think it's still happening like that, it is that you should use the local soil. So it's not about, okay, let's use the soil from this island, grab it and bring it somewhere else. That's defeat the purpose. So the concept of using earth material to minimize embodied energy or to minimize environmental impact is you used to use the local soil. If it's not the soil, because sometimes the soil is not available, then you should question that. And you just say, well, don't use that earth material because it's not suitable for that local environment or local context. So once again, it should not be about taking the soil for somewhere else and bring it to that area. If the soil of that area is not suitable, don't build earth construction. Okay, so I don't think the concept of earth construction is not going to be over exploiting soil, because that just defeats the whole purpose. In terms of how is it impacting local force, especially in developing countries, look, to be honest, as I wrote there, it was my main concern when Muhammad first brought it up to me, and I said, you know, what happened with the local people? If that's their bread and butter, you know, they have to build construction. His argument is, as in many things in the world, things are changing. If an area started to adopt, say, 3D printing technology, then hopefully the workers that or laborers that tend to work by building, they can be retrained. They might be retrained to become operator of the 3D printer, for example, or they might be retrained and they do the finishing rather than the building itself. And the argument, I think, makes sense, because if you think about it, what happened with post offices nowadays? We now use mobile phone a lot. We even transfer money using internet. So we can question the same thing. What happened with people who work in bank? What do they do now? So some of them, as far as I know, they changed. They become retrained, and they probably open, I don't know, some more internet business rather than bank-based transaction. People who used to work in post offices, or when post offices are closed, then they do something else. I think that just unfortunately, but it probably is fortunately, that's how it is. I guess people just change, and we just got retrained and we do something else. Once again, however, in my view, if the local people are not willing to adopt this new technology, then obviously we should not impose on it. So I think it's only suitable for a context where it is needed. So I guess the idea is really about, for example, as I mentioned before, it is quite suitable for remote areas or disastrous areas. So there's a, say, earthquake, and the local road infrastructure just got destroyed, and you just cannot bring big trucks anymore. With 3D printing technology, all you need is smaller truck. You put the robotic arm on it, off you go, put it on the local site, and hopefully if the local materials are suitable, then you can use it to print it. So it should not be something to be imposed. Lastly, I just want to say that, again, his argument is, in many countries, 3D printing technology started to come. Like it's just like same thing. You know, many years ago, mobile phone doesn't exist. Now everybody has mobile phone. His argument is 3D printing may start to influence the building construction industry. What do we do? currently most 3D printed buildings are of concrete, and that's his concern. Why can't we use local materials? If this technology is coming anyway, can we do better using local materials? So it's really not about changing, let's change the whole way of we build buildings, because 3D printing cannot solve everything. But when it is unavoided, what can we do better? I think that's the main point of that. So hopefully that answered the questions. Does it answer the question? I mean, look, we're open to discussion, of course.
Yeah. Okay. Thank you so much, Bu Ira, for your answer. I think yeah, I can agree that 3D printing really offers big promises for the construction, and then it is too great to ignore. I mean, especially because obviously it will create less waste, and then also in the long term it can be a solution to like to sustainability too, but maybe it will be used first in the developed countries before it can be used like widely in the developing areas like Indonesia maybe. So
yeah. Probably, I just want to say that actually Saudi Arabia now started to implement this. So Mohammed's, he's from Egypt, but his friend is actually from Saudi Arabia, and he was doing comparison with what happened in Saudi Arabia. In Saudi Arabia, mostly they use concrete still, and he tried to argue, try to use local material. So in a way, it is happening even in kind of developing countries as well.
Yeah. Because the pace of the construction is also very high there, I think. Yeah.
Correct. Yes.
Okay, so we have other questions for for Mas Handi, but actually I just want to inform you that all attendees can ask questions, and if you want to ask questions live, you can just raise your hand. You can use the raise hand feature in the Zoom. So yeah, so while waiting for someone to ask live, maybe we can just continue to Q&A. So dear Mas Handi, your design experience is very impressive. I have questions. There are more problems about maintenance of using contemporary materials like this, especially in large scale using. Do you have experience about this from Dina? Maybe Handi, you would like to answer this live too?
Hello. Is that a live question or in Q&A? I think I have answered that question in Q&A section.
Okay.
From Dila. So, what's the question again?
Sorry. Your experience regarding the problem of
Dina, yeah. I've answered the question. So, especially in large scale, do you have experience about that? Yes. Actually, one of our oldest project is the gate at the Vida Bekasi, and it has been lost for more than 10 years without any maintenance, and it is still going well until now. So I think it is very low maintenance, especially if it's used for facade or for second skin of the building, because it has no pressure on the material, so it's only dealing with the weather, like extreme weather. So I think if it's very hot, I think the material will be adapt with the weather. And uh, if it's like if you afraid of having excessive dust, or it can collect dust or something for facade, I think the rain will be can easily remove the dust and everything. So it is very low maintenance from my side. Yeah.
So yeah, I think it clearly answers the questions, and everyone loves low maintenance concept.
Yeah, yeah,
So,
yeah,
so
yeah.
I think we will go back to 3D printing. We have questions for Pak Popo Danes from Dila. Actually, Dila asked two questions, one for Popo Danes and one for Handi. Dear Pak Popo Danes, what do you think about building with 3D printing in remote areas as mentioned by Ibu Ira? Is it feasible to do in Indonesia if one day we can afford the printer? And also for Mr. Handi, have Byo Living considered to use 3D printing technology for future development? If yes, how will you combine the balance between technology and craftsmanship of the worker? Thank you. Mungkin Pak Popo wants to answer first.
Yes, thank you, Novia. So for the 3D printing, Dila said, when it is affordable. But of course, in every project, we are always thinking about what is the most optimum system for today. Yeah, what is more efficient? And of course, on the other hand, what is more green for our current condition? And to me, as of course, technology-wise, that will be possible, but whether this is the priority or not for the time being. Yeah, because through my presentation, I've been showing about some of the good practice, I would say, good practice of doing architecture in our situation. Probably that was my personal situation, but I think I could also represent so many other cases of Indonesia, yeah, so many other experience of Indonesia, because we are dealing with the same kind of situation. That's my opinion about 3D printing. But in terms of the use of the technology, I think it will be great if the 3D printing later on can help us for probably some special detailing, which is probably not possible to be done by a local traditional craft, or especially if we are trying to put a specific kind of accent or elements. That also could be possible, because design and art is to me is unlimited, and whoever can contribute with whatever best they can do, that will be good to help us in creating the best collaborative kind of design product. Thank you.
Totally
Thank you,
agree,
Popo.
Popo. I think that's a really great thing. You know, I think 3D printing could be used for, for creating intricate details, for example, that is really hard to do. I guess, unfortunately, a lot of people, you know, they started losing the skills that probably the grandparents were able to do in the past. And it can offer that possibility. But I totally agree with you. It's whatever is more contextual. I think you cannot force technology just for the sake of the technology.
Yeah, I think let's say that we can start small because obviously 3D printing will benefits in the future. I mean, in cost savings and environmental friendliness too for the building's future. But yeah, maybe we can start small because I think obviously it is a big investment. I mean, so what about Mr. Handi? Have Byo Living consider using 3D printing in the future?
Yes. Yes, we are going toward digital and rapid prototyping as well. For now, we are using 3D printer for making like a mock-up or details in joinery. So it will help us to translate from to understand the development and the detail of the product. So I think by using latest technology also can help the craftsman to streamline the process, especially if it's related to decoding complicated pattern or joinery. The craftsman also can be more focused on delivering their best quality, so they don't distracted by the system or the management, or they don't think about the design. They just can delivering their best quality for the product. So I think uh, that's the benefit for the craftsman, modern craftsmanship right now.
Oh, okay, I think it is a very good approach for Byo Living to start using the 3D printing technology. Uh, and also we have some questions too from Ibu Afianti Arman to Pak Popo and Handi. Ibu Afianti, maybe do you want to ask live, or I just read the questions?
I think I can also answer this here.
Oh, okay.
Yeah.
Okay.
I think so. If I may, I will ask. I would answer two questions from Mas Wido and Bu Afianti. Both of them are my good friend. Yeah, the main issue on these traditional buildings are fire hazard. What is the solution? So for Pak Wido's question, my answer is like, luckily for most of the project, we are also dealing together with the hotel operator. So there always a manual, design manual that we have to follow together with their system. So we never just decide to make a design without any discussion with all of these people. And we are also always supported by some good engineering people. And we found if Mas Wido talking about the fire hazard in the traditional building, most of the cases was happening due to the terrible connection of some electricity cabling. So because in the remote village, especially in Indonesia or in the traditional situation, they never designed the electrical system, of course. So they just pull one cable and connect to another cable, and suddenly they have a very complicated cabling system. And one bad connection could create the big fire to all over the place. So in the kind of industrial building as what we design, of course, the look is very much traditional. The look of the entire setting is very much like the traditional village, but we are always supported by a good system and covered in every level. Like first, the installation itself must be well designed, and of course another level of protection. Maybe if we don't have the sprinkler system or fire hydrant, we will put the portable extinguisher, or like at least we will set like some assembly point. If a kind of fire happen, then the assembly point will be this and this and this, and it will come together with the building operational manual. So that's what happened in our situation, and so far we are always good because the operational of the building itself is always done in the appropriate way. They always have the engineering maintenance team on site. So luckily we never have that issue, and hopefully never. That's for Mas Wido. And to Ibu Afianti Arman, would you do if you have a project in the urban setting? What kind of approach in choosing materials? What in urban setting? Yeah, we do some work in the urban setting, and like that restaurant in Lombok, the Rumah Langko, was a very much urban setting project, and I think I could consider that project as the landmark of the city today. Yeah, because maybe that is one of the biggest size of the still exists old structure of modern building, modern architecture, and of course in the urban setting, our sensibility will shift to some other part, because in the urban area we do have another issue of maintenance as well, because in the urban area of Indonesia, one of the issue is the dust. Yeah, we always have a lot of dust with the heat, and then maybe the setting of indoor and outdoor composition will be different as well. So not only the material selection, but the way we set the building and the spacing will be different. So I don't think we have an issue, but of course, if we still would like to have some special local or creative signature in the project, that's always possible, because we still can include some of those elements probably when it is too difficult for the exterior, and we will put them in the interior, for instance, or vice versa. So that's my answer. Thank you.
Thank you, Pak Popo,
Hey,
for
Mas.
your answer.
Hey, nice to see you.
Nice to see you again. Good presentation. I like your designs. However, most fires not always is caused by electrical short circuit. Some also caused because of global warming, and the climate is getting very hot. Yes, and the reason why we're using sustainable materials, of course, is to stop global warming. However, with this heat, some of the buildings can easily catch fire even by lightning or other causes. Even wood rubbing together can cause fire. So is there any idea of using other technologies or materials that can use as a fire retardant, making these woods anti-fire or fireproof? I think we should consider that, because I think just training the residents or the people surrounding the buildings is not enough. When one of these buildings catch fire, even the most sophisticated fire extinguisher cannot stop it, you know. So I think if we're talking about technology, I think we have to find a technology that can easily extinguish the fire immediately. Yeah, thank you.
Okay, thank you, Mas Wido. Yeah, of course, I forgot to also mention earlier that fire retardant system also applied normally, because like, let's say if we have the thatch roof, we can have a special spray material to protect them, at least to hopefully not happen, but to slow down if in the case of fire, to slow down the move of the fire. And for your other comment about the lightning as well, because even it's a traditional look of architecture, we also put the lightning arrestor. Yeah, the mechanical electrical guy normally will include that in the design. So, but I think I hope we are not too scared to use the identity of our local architecture just because of some technical reason. So we will find together the way how can we solve one or the other issue, and every engineer and expert can collaborate together to create their best work. Thank you.
Okay, thank you very much.
Okay.
Sorry, I just want to say, is that Wido? Wido, Arsitek 81? Hey, Wido, where are you?
This is kind of reunion.
Could I just add one more thing? What Wido was saying. Could I just say something, Novia?
Yes.
And
yeah, perhaps, I don't know. I'd like to know what Pak Popo would think about it, because I know earth construction at least in Australia, it has been shown that when there's fire in Victoria, the earth construction tend to stand. It could withstand this, extreme heat as well as fire itself. So it is a possibility that one way of doing it is, rethinking the materials that we use. That's just want to know what Popo would think about it. But also, I think in terms of dealing with fire, it is a very tricky issue. However, I think it's not just, it cannot be solved just by the building. I think it's the whole, site planning, what happened around the building, how we manage the trees and how we manage the grass, and, do we have enough water around? So it's a whole complex of issues that cannot be just solved by having sort of fire-prone buildings, because even with fire-prone buildings, because we always have glass, for example, glass windows. So the question is, and often that's the glass that breaks, the building probably stand, but the glass that breaks. And also the issue with fire is often the ember, the percikan api, that's the one that goes under the roof and then get caught and then start to create fire and so on. So the detailing of the roof becomes a problem or becomes an issue, has to be solved and so on. So it's not just the material. I think it's like a lot of different things that need to be worked out together. But it is true, I think what Wido said, that, what happened in South Australia last year, early this year, in the place called Kangaroo Island, just because it's just so hot and the fire just light up just like that, lit up just like that. And it is quite scary, but also it also has to do with the landscape. So less attention was paid to maintaining the weeds or the grass, and they let the grass grow too long, and then the minute just a little fire trigger the fire, and then it just went very quickly. So I guess it's sort of pretty complex issue that cannot be solved just by the building. But yeah, I just want to know what Papa would think of if you have. I know earth construction is not very typical in Indonesia, but would you consider that?
Oh yeah, the earth construction, we also have it in Bali, yeah. But you remind me about one construction method from India, the Agni-jata, where they actually burn the terracotta and to the mud as a shape of structure and burn them to become the structure. This is also possible. And also the other case of earth construction, if I may jump to another kind of subject, because this is also interesting. I've been learning about the ramp earth in Australia, mostly in Margaret River, compared to some of the ramp earth technique in Europe. And I found the Australian, they are more realistic, because for the Australian standard, they always allow to add a 5% of cement into the
stabilizing it,
to stabilize them. But in Europe, they are more fanatic. It must be purely done by earth. But this is also giving the impact to the durability of the
Hi, Veronica. Professor Veronica, nice to see you again. It is me.
Who's that? Is that Wido?
Yes.
Don't call me professor. Come on, Wido. You're my friend.
Yeah. Yeah, that's my opinion. So okay. I think we can treat the earth material in a different way. Yeah. Thank you.
Okay. I also just later if we have time, I just want to suggest one more thing, but later. That's okay. There's another possibility, but yeah, later.
Okay, so maybe we can move on to the next questions. Actually, there's questions for all speakers, how far do you, from Pak Andy Subiono, how far do you think technology could help architects? Previously with CAD architects, with AutoCAD architects could make forms that could never be done by hands. And in coming era, IoT, AI, and holographic approach will obviously giving influence to architects and architecture. Also, a following question is, when this happen, what do you think will happen to natural materials like woods and brick wall? Thank you. Maybe who wants to go first? Can Pak Popo, Bu Ira, or Handi?
Whoever, go ahead.
Yeah, whoever. I'm happy to answer first if I may take
Okay,
the time.
please, Pak Popo, you can go first.
I mean, yeah, I can feel that when we start using the CAD, and suddenly it's so easy to make the curve, for instance, yeah. So to create all of this angle and that angle, so it's not as traditional. The shaping of the building design is not as traditional as when we use the ruler, for instance. But yeah, in our case here, we are also always trying to check the compatibility between the design it's not that as easy as to draw them. So this is always yeah, I'm taking a practical approach. We are always taking what is available to support this design. And of course, we like to make our design as playful as we can, yeah, in terms of shape, in terms of elements and everything. So for the material as well, I think we are moving forward in our organic way. Like after we have an issue of the availability of wood, then we have another option whether we are using the engineered wood or recycled wood, or later on we will have a synthetic wood, for instance, from another material. So I think everybody will keep doing their best to support the industry. I consider this as an industry because this is a contribution of every disciplines. Yeah, everybody will do their best. I mean, it's fair whether they are in the intellectual side or in the market side and the manufacturing side. It's good for us to listen to each other to strengthen our capability in the future. So yeah, that's my answer to Mas Andy. Thank you.
So how about Bu Ira?
Yeah, I think,
Handi?
you know, as Papa said, I think, again, I don't think we will not have timber or wood as natural material, even though we may change. If that's the only natural resource that is available for that particular site, people probably would still continue to build that. I think the more for the future, I think the question is always, okay, if we use that material, can we renew it? What is the impact of using that material? Obviously, we should not exploit it and just, you know, just use any timber we have and then never replace it with or replant the timber. But I think in the future, I think people probably would still have, it's the same question like, you know, when you see in any development, you know, we used to have horse-ridden cart and we used horses to travel, and then we started inventing cars, and then we got I don't know, racing cars, we got, you know, now it's electric car and so on. And at the time we wonder, oh, what happened with bicycles? Yeah, some people still ride bicycles, so I don't think it will ever disappear. It really depends on the context, and we would need it. But I just want to say about bricks, however, fire bricks that we often use do have high environmental impact. So I think it is time for us to rethink how we make bricks, because fire bricks do have a lot, you know, there's pollution, there's embodied energy, there's a lot of other things. That's why I think probably we need to think about the better non-fire bricks. So earth-based, you know, just with drying bricks naturally is probably better, but also, but of course, I acknowledge in the hot, humid climate, it would be harder because when you start having rain, you know, you cannot just put bricks outside. In Australia, it is possible. You don't have to use fire bricks because in general, we got a lot of dry climate, so it's quite easy. My friends used to make bricks by hand, and they built a house just using that. It's never fire bricks, so it's just, you know, the mix and then just dry it. But I think we should rethink about bricks that we know, because they do have high embodied energy.
Okay, thank you, Ibu Veronica. What about Handi? Do you want to respond to the questions? Maybe the AI approach or holographic approach will obviously give influence. What about the from your perspective as a material manufacturer, from the manufacturing side, what do you think about this more modern approach? Will it influence like the rattan, your rattan in Byo Living?
Yeah, I think it is very interesting, and it's gonna be way more. Uh, I think it's way more interesting to look at the future of the materiality and the technology. Uh, I think yeah, it's gonna be open more opportunities, and then more open more creativity to explore more design and technique and production process by using technologies and latest technique. I think like that. Yeah, that's my opinion.
Okay, so next we have questions to Pak Popo Danes from Pak Markus Sugiaman. Maybe Pak Markus, you want to ask live? Please, you may ask directly. So the question is, okay. Halo Pak Markus.
Hello, Novi. Hi, Pak Popo. Selamat sore. By the way, I know your name. We are very know about you, about your project. Well, just short question, because we are talking about the very good quality materials, not only from your perspective, but from Ibu Veronica, and also the waving, a very interesting waving from Byo Living. But most of this materials is quote unquote a bit expensive. So we are facing the problems when we are handling the projects that the owners really concerned about the budget. So what's how you work about this with this situation? That's it. That's all.
Yes, I can answer your question. So every project, of course, it has also its own mindset of the project, where the project going to go, yeah, the direction of the project. Some project is going to be constructed for a pride. Some projects going to be constructed for a business reason. So, but as an architect also, we are always trying to think about what is the most sensible answer for our issue of our problem. So of course, the sustainable materials are becoming more expensive, but sustainable materials also is not a priority for every project, because in every project, most of them have the economic aspect that the designer have to consider as well. So we always have the scale of priority, whether that material really need to be there or to become the special highlight of the design. So then we can do it, we can work it out, and we can decide. So it's something very fluid, actually, in my opinion, yeah, about the use of material, and of course, either when the good material, either sustainable or not sustainable material, are affordable for the project, but we are also always have to think whether it is sustainable or not. Yeah, so this is come back and forward as an issue and an answer. So then normally we will come up with the decision through some collaborative discussion, what is actually the priority and the best solution for it. It's quite flexible, I think. Thank you, Pak Markus.
Okay, thank you Pak Popo. Mungkin sebelum Pak Markus, before Pak Markus respond to it, I just got the info that Handi, it looks like Handi just need to leave now. Do you have any other agendas?
Yeah, actually, I am in the middle of evaluation meeting with the Ministry of Trade right now, but the event is over and I get to catch another schedule in Jakarta. So apologies that I have to leave early, and thank you for having me in this webinar. I'm feeling so honored to be part of this and learn a lot from another panelist and also the attendees. So izin pamit
Yeah,
dulu.
thank you so much for your time. Maybe you can give us a closing statement before you leave.
So yeah, I think we have to keep searching and keep looking for another opportunity to use like a natural material and explore more about the Indonesian craftsmanship and the local wisdom in Indonesia, because there are so many value that we can use and we can promote to the international in the world of architecture and design. So I think that's all.
Okay, thank you so much for your time.
Thank you so much.
Andy, you got really beautiful architecture there. Beautiful work. Beautiful work.
Thank you. Thank you.
Okay, see you again later.
Bye.
Bye. So we'll go back to Pak Markus. Maybe Pak Markus wanted to say something.
Okay, sorry, I have problem with my videos. Thanks for your comment, Pak Popo, but we agree that good quality materials and sustainable material is always expensive, right? So that is our challenge to fight and how to educate the clients to follow our recommendation. And it's very big challenge for us. Yeah. Maybe we need someone to help, maybe from the government, something like support from the governments to, if you have a good client like Marriott or good hotel operators, they have their own standards, so we can just follow their standards and the owners has to follow. But we are facing not the ideal situation when the owners just thinking about budget and budget. that's the fact. Okay, that's yeah, we are facing the same problem. Yeah. Okay, Pak. Thank you, Pak.
Could I just comment on some? Oh, sorry, Pak. Sorry.
Okay.
Oh, I just want to comment on what you said. I don't think all sustainable materials are more expensive. The issue to me also is, I guess, the more we use it, I think the less expensive it becomes. So I guess as architects, if we can, as you probably just suggested more and more to our clients to understand the importance of using sustainable materials and doing things sustainably. And if we can have more people demanding it, I think the cost will go down, not automatically, but eventually. I just want to give an example. For example, in Australia, so about probably 15 years ago, the cost of solar panel at the time was so expensive, and there's only a few people who can afford it, so you don't have that. However, because more people want to have solar panels, because then they don't have to rely on electricity from the power generation and so on. Now you can get probably twice, if not 3 times the size of the panels from 15 years ago. And the cost has gone down to almost 1/3 or if not 1/4 of it, because there's more demand and then the cost just goes down. So I think probably it could be the same with sustainable materials. If more people demanding it, it becomes a norm, and it's a good thing, right? Because now we create better buildings. and also the cost goes down. So let's encourage our clients to embrace this concept of sustainability even more to help bring the cost down. That's my view.
Thank you, Wira, and I agree with you. Let's educate more our clients too, and ask them to join us in using the new technology and materials. So for all attendees, I just want to remind you that we have a form that you could fill to get the e-certificates. You can check the link in our chat room. So I think almost all questions have been answered. I think. Oh, I think someone wants to go live. Maybe we still have time. Atika, maybe Brian, you could, before we have the closing statement from each of our speakers, maybe Atika wants to say something. We have opened your access, so you may. Oh, okay, maybe we can skip. So maybe now we can ask for Pak Popo and Bu Ira to give closing statements for our session today before we close the session.
Pak Popo,
yes. Yeah, thank you, Ira. So thank you for the opportunity to talk first. And I think this is a good opportunity for us to know each other in a better way. We are developing a good network. This afternoon, we found some new good friends. And I think I have to value all of the question and comments from our friends at the most valuable way, because I think we cannot think only using our own brain, and with somebody else's opinion, I think we can develop ourselves in a much stronger way, and widen up our mindset, especially when we are dealing with some design issue in the project. So I'm very glad that you invite me to become part of this agenda, important agenda. It's very meaningful to me. Thank you very much to Arkitekton Lima, especially my dear friend, Ibu Cikita Pitono. And I hope we will do this kind of session again later on. And of course, as the next session, we also always expect the quality will be better, and we have a better audience, bigger audience, and also some more good speakers. Thank you. Good evening to all of you.
Thank
well,
you.
sorry. Yep.
Oh yeah. Thank you, Pak
Something
Popo. Maybe you can start, Bu Vero.
Yep, Popo, it's really nice meeting with you. I heard of your name, so it's great to listen to you directly. Thank you to Mbak Cik. It was a surprise call, but thanks for asking for me to share some of the work that we are doing here. And it's just great for me, really, to see names of people that I know. Unfortunately, not everybody, I can see everybody on the screen. Some old friends and friends from work. Ibu Rini, I think I saw you there. Wido Mas Nuk. Sorry, I just have to do a bit of reunion here. But thanks so much. So it's been great. I have to say thank you, particularly for Arkitekton. I think this event, this webinar has been really fantastic, just to see the interaction and the creativity and amazing work, Pak Popo and Handi, and I'm sure many other people in Indonesia. It's really, really fantastic. And I have to say also, thank God for COVID, because if COVID didn't happen, I don't think I would have time to talk to you or would be invited to speak, because we don't need, like you probably would have the talk or the session face to face, not virtually, but because of COVID, you invited me. So thank you. Because otherwise, if you invite me, you have to send a ticket. So that would be quite expensive. So I'm glad that we can talk virtually. And please, if you don't mind, put me in the loop, put me in your mailing list. I would love to attend the next webinar that you will be organizing. But back to the issue of this building materials or construction techniques and so on, I think architects really have the ability, creativity to think outside the square. And I think it's really an opportunity for us really to make a better world, to make a better built environment. The impact of us, I mean, in the past, we tend to just design and design, for the sake of designing. But we now realize that we have a big role to play. And that big role to me is challenging, but at the same time giving us a lot of opportunities, I should say, to really make a difference in our society. So let's keep working together. I agree. If you do need to investigate further, to research further, to look at things in more detail, and if some of you are interested, come to Adelaide. I'll be happy to supervise your PhD when the border is open again. Otherwise, we can continue collaborating in any way we can. So thanks again for Novia, for everybody, for Mbak Chiquita once again, Mas Toga, and yeah, see you in future opportunity. So good night.
Thank you so much, Ibu Ira and Pak Popo. Maybe for the closing, from Arkitekton, maybe Pak Toga or Pak Jaya wants to give a closing statement before we end the session. So we have 7 minutes left.
Right?
We have 7 minutes left, Pak Jaya.
Okay, thanks a lot. This is my opportunity to say thanks again to Ira and Pak Popo. It's long time no see you, Pak Popo, in Bali last time. Maybe you've forgotten to say yeah, during the Rakernas CII. Yeah.
No, I still remember you, Pak Jaya. Of course.
Yeah, and again, yeah, this is our birthday, Arkitekton's birthday. It's great to have you, yeah, to have you in this session, and to make the what is it? To make Arkitekton more alive, yeah, Arkitekton more alive, maybe, hopefully, because the COVID seems to make us very, like dark cloud in our profession. Yeah, I don't know, Pak Popo. Maybe Pak Popo international, well known. Yeah, yeah, lots project. We hopefully next year, in 2021, yeah, will be better in our profession, and also will be better everywhere, everywhere in Australia as well. And Bu Ira, it's long time also not to see you here in Brisbane. Hopefully next year we can go to Australia and visit Bu Ira, visit other friends in Melbourne and in Canberra as well. Thanks a lot again. Yeah.
Yeah, okay. Thank you, Pak Jaya. Hopefully next year we can all meet together. So maybe Pak Toga wants to give the last closing statement, the last 5 minutes from Arkitekton.
Okay, can everybody hear me? I hope so.
Yeah,
Right. First of all, to Mr. Popo Danes. Actually, I have never met you, but your name has already been in my memory. So when my staff picked your name, And I told them, yes, go ahead and get him to this webinar. And they get it you. Yeah, they got you. Thank you for
Thank you, Pak.
Mr. Popo Danes. Yeah. And also Ira, my ex-supervisor in Adelaide. Although I could not continue, but I really appreciate your being as my supervisor. Now, about this webinar, we have talked a lot of technology. We are actually a creator of making tools. People make tools, human being make tools. And this technology, the latest technology that we call the 3D printing is a tool. Yeah. And that is how we have been through our evolution, that we always create tools as the expansion of our human body. And that's what we do. So it comes, the argument, it comes to whether these tools can be used with, not so expensive or expensive. That goes to the law of economy. When they need and there's a demand, the technology will prevail, such technology will prevail, or even become more better in the future. Okay. Now, the other thing that we could twist this, let's say next webinar, is what does the technology brings to human being actually? We may not have touched uh, this aspect, such as when there were about this machine that can make details of a wonderful sculpture. Yes, of course, and it's even become they can make even more better than the hands of human being. But the hands of human being, when they make sculpture, it's not about all the product. It's about being making something. So I think in the future we can actually technology and human being. That's all. Thank you.
Okay, thank you very much Pak Toga. Pas 2 menit terakhir. So I just want to say thank you for all our speakers and Pak Toga, Pak Jaya, Bucik, our friends from Arkitekton, for Anabata, Brian, and for our sponsors, Byo Living and our media, Asahimas, and then our media partners, Arsitek and Archify. Thank you so much. Thank you so much for all participants for having your time here to join our webinar. So thank you and see you again in our next opportunity. Bye.
Thanks, everyone.
Thank
Bye.
you.
Thank you.
Thank you, everyone. Thank you.
Merry Christmas. Happy New Year.
Good night.
Merry Christmas. Bye.
Bye, love.